All right, I'm going to make a quick video here to help you guys review. What we're going to be doing for the next, week or so is I don't want to start anything new now that we've finished magnetism. What I want to do is look back at everything that we learned during the year and kind of review. If we were in school, we'd have a Q3 exam, which I'm trying to figure out how to give that to you without, overwhelming you and also making it fair. But in an attempt to review, we're going to go all the way back to motion or kinematics, if you remember the name of it. It's just a big word that means motion. I'm going to try and keep this video under 10 minutes. And then I assigned Castle Learning, maybe like 10 or 15 questions. Some of them are numeric. Others are just, conceptual type questions. So first things first, I guess I'm going to go through some of the equations really quickly because those questions aren't too bad. I hope you're learning that over time here, that if you can just read, underline, and kind of write what letter corresponds, then it just turns into a little bit of a math problem, and we don't try and make them too difficult. So this is your average speed or your average velocity. Let's call this the average speed, and we're going to put it as distance over time, so d over t. If it was average velocity, I would put an arrow on top, and then it would be displacement over time. In class, if you remember, instead of using d twice, I used delta x over time. And that delta x is the displacement. And if you remember, might as well draw it right here. If you have a starting position, right there, and a final spot right there. Let's say you went up, over, this way, and then down, and like that. Some weird path that you took. The distance would take into account this entire path. That would be your distance. But your displacement just cares about start to finish. So it just cares about from this point, I don't want to select it, cancel. Just cares about that right there. And the direction of it, again, because it's a vector, it has a direction, would be, north of east. And you could, if you really wanted, you could come up with an angle for that. So distance, you count, everything. Displacement, you just care about that straight line distance start to finish. All right, some other equations that we use, I'm going to go back to green, are when you have A, that's your acceleration, your average acceleration. That's your change in velocity over your change in time. So that's V final minus V initial over your time. We can rewrite this as V final equals V initial plus A times T. And again, this only works when A is constant. We called these equations the big three, if you remember. There was VF squared equals V initial squared plus 2A times D. And then there was one more, D equals V initial times T plus 1/2 A T squared. Again, all of these work when A is constant. So you'd be told that in questions. And I'm going to give you a few questions where you have to solve for these with the Castle Learning. Like I said, watch this in the morning and then try this afterward. And that should take you, about a half hour or so, especially if I keep this under 10 minutes. And we're already at 4 minutes. So I'm moving right along here. Again, understand what these stand for. The extra letters are to make your life easier. F stands for final, I stands for initial. Okay, let's see, what else do we need to know? We need to know about vectors, the idea of they have a direction and a magnitude. Direction is kind of obvious. The word magnitude just means the size of the number. Let's see, what else do we have? I'm going to pause this for 1 second. All right, let me get a new page here. That's not what I wanted. I don't know what the new page is. I guess I can just clear the entire thing. Some other things that you need to know, graphs. I'll go to black for this. There's a couple different graphs that we'll do. We'll do D versus T or X. V versus T, and A versus T. Remember, if this is a straight line, the slope of this is your change in D, that's on the Y, and delta T is on the X. So the slope is equal to change in D over change in D. If you look back, a minute ago, you would have seen that that is the definition of what V is. It's D over T. So the slope of this equals your speed. If it's distance, if it's displacement, it's your velocity. Same thing here. If you have a straight line, you can calculate a slope with change in V is your Y, that's your rise, and your run is change in T. Again, delta V over delta T has meaning, that's your acceleration. And you're going to get off easy on this one. A is either going to be this or it's going to be this. This means A is constant, and we can use those big three equations. This means A is 0, and we don't have any acceleration. Now, if we work backwards from the acceleration graph here, if A is constant, that means V is constantly going up or constantly going down. So that's what this shows you right here. Now, if that's happening, your distance is going to be increasing in a curved manner. So that would correspond to that. That would correspond to that also. This would be speeding up. If you guys remember, I talked about a pencil test where if you laid your pencil, grab an orange pencil. If you laid your pencil down like this, the slope would be 0. If you lay your pencil like that, the slope is increasing, the slope is increasing, the slope is increasing. Conversely, we could do a slope that is decreasing. This would be something that's slowing down. Your slope is high, medium, and then it's 0. So this is decelerating. This one is accelerating. Okay? If you have this right here, a constant V, and maybe I'll change it to purple because I haven't used that color yet to circle it. If that's a straight line, which means a constant speed, a constant slope, that would imply a straight line there. Okay? What's next? All right, the last thing I'm going to talk about is kind of projectile motion. The idea of things flying through the air, a football being kicked, a soccer ball being kicked, a baseball hit, a dancer jumping through the air. If we want a lacrosse ball being fired, where you have some angle that it's launched at with some initial velocity. Some things to remember, at 45 degrees, in physics fantasy land, that gives us the maximum, what's called the range or the distance in the x direction. Some other things, x or horizontal, some other things that we remember at the top here, the ball or dancer is not going up or down. So V in the vertical direction is 0. If we shot something straight up in the air and waited for it to come back down, V at the top, we would say 0. When we have these things, the acceleration is known. And in the x direction, there's no rocket behind these things, no fans, no propellers. So in the x direction, right, we break this into x and y, horizontal and vertical motion. This means there's no acceleration. So V in the x direction stays constant. Gotta be able to spell constant. A in the y, if you remember, is that gravitational field strength or the acceleration due to gravity. It's negative 9.8 meters per second squared. The negative just means it's acting down. So you have to pay attention to your signs all the time here. We have to pick, usually right and up are positive, left and down are negative. So keep track of your signs, especially when you use those big three equations for this. We won't do too much in 2 dimensions, but we will do, things going up and coming back down. So just in the y, just remember that A, you're going to substitute that for it. All right, that's all I have for today. I kept it under 10 minutes. So thanks for watching this. Take a look at the Castle Learning. It's assigned in there, so just log in and do what you need to do.